Okay guys, here we go. We're going to share with you this applet from GeoGebra, and I'll post a link for this as well. Okay, and what I have here is the unit circle, and we're going to restrict ourselves to looking at the radian measures. Okay, remember radian measure um, is dependent on the angle, the central angle that's swept out here. And remember, it is the ratio of the arc length, as shown here in red, over the radius, okay? The arc length in red over the radius. Of course, if we're going all the way around the circle, that would be, the entire circumference, then the entire circumference is 2 pi r divided by r is just 2 pi. So one revolution around the circle is 2 pi radians. So here we go. Our first stop is at the pi over 6 radian measure. Does correspond to 30. We're not going to translate, but it does correspond to 30. Okay. The pi over 4. Okay. The pi over 3. Okay. Pi over 3 being 1/3 of pi, being that, okay, this arc length, okay, is 1/3 the entire arc length swept around the swept around halfway around the circle. Okay, so here you can see a third of uh, the semicircle. Okay, that this arc length produces. Okay, pi over 2 is at straight up at what you would think of as 90 degrees. Okay, our reference angles now are real easy, because if I'm pi over 6 short of half a revolution, that's right here. That's 5 pi over 6. And the reference angle right here is pi over 6. Pi over 6, okay? So the angles have the reference angles indicated in their denominator, okay? If I have a reference angle of pi over 4 in quadrant 2, I have a 3 pi over 4 sweep. That's it. The arc length over here, shown in red, is 3 pi over 4. But the reference angle is pi over 4. 2 pi over 3, okay, corresponding to, okay, 120 degrees, if you will, has a reference angle of 60 degrees, okay, or pi over 3, pi over 3. In the third quadrant, with a reference angle of pi over 6, is pi over 6 larger than pi? Pi over 6 larger than pi is 7 pi over 6. In the third quadrant, with a reference angle of pi over 4, meaning that it goes pi over 4 beyond the semicircle sweep, which is 5 pi over 4. Again, third quadrant, reference angle with pi over 4. 4 pi over 3, 4 pi over 3, a 60 degree sweep, or a pi over 3 radian sweep into the third quadrant, okay, with, okay, 4 pi over 3. 3 pi over 2, okay, 3/4 of the way around the circle, okay, going into the fourth quadrant with a pi over 6 short of a full 2 pi revolution. 2 pi would be 12 pi over 6. And if I'm short by pi over 6, I'm at 11 pi over 6, okay? Referenced angle, reference at pi over 4 in quadrant 4 is 7 pi over 4. Reference angle at pi over 3 in the fourth quadrant is pi over 3. This is good. You should look at this completely and understand it, okay? So we have the pi over 6 in quadrant 1. We've got the 5 pi over 6 in quadrant 2. We've got the 7 pi over 6 in quadrant 3, and we got the 11 pi over 6, all with reference angles of pi over 6. Okay, all with reference angles of pi over 6. Pi over 4 references include pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Okay, pi over 6 reference angles, of course, include pi over 6, 2 pi over 6, 2 pi over 6, I'm sorry, pi over 3 reference, 2 pi over 3, pi over 3, 4 pi over 3, and 5 pi over 3. Okay? All these can looked at as, we could look at the negatives. There's a, shown in green here, the negative pi over 3 sweep. Okay? Again, having a negative sweep sends it in the clockwise direction, ending up in the fourth quadrant with a pi over 4 reference angle. Okay? Or a pi over 3 reference angle, I'm sorry, as it's shown here. Okay? The negative 2 pi over 3 sweep, as you can see, ends up here. Okay? We could have the negative 4 pi over 3. Okay? Or the negative 5 pi over 3. Okay? I think this could be very valuable for you. Therefore, I'm going to load the link on this as well as this video.